Welcome. Thanks for joining me today. We're going to talk about how to draw a ray diagram for a plane mirror. So remember that this term plane isn't the sort of term we think about in terms of, say, ordinary or usual. Plane means that it is a two-dimensional mirror or a flat mirror. So this would be when, say, you're in the bathroom standing in front of a perfectly flat mirror, as opposed to mirrors that we will do later, which will be curved. All right, so the first thing we want to do is sketch the mirror. And we sketch the mirror as a vertical line. Now later on when we do problems and the mirror maybe is at an angle or something, then things will change. But in general, if we're just sketching a situation, it's always really helpful to just make the mirror a vertical line, and the vertical line will go straight down the middle of the page. I like to label that this is the mirror so I know what that line represents, and I also like to label the front of the mirror. That way we know where's the object and where will the image be. The second thing is we draw the object, and whatever object you do, you need to make a dot somewhere, and the dot is located, for our case in this, at the middle of the object, but later on it'll be wherever the light is starting from. So I'm just going to pick an arbitrary spot. Let's say my object, as we did with our lab, is circular. Always a good idea to label it O for object. Then what we need to do is draw the corresponding image. Now, the image always must be located behind the mirror, and not just behind the mirror, but in a very special way, so that the distance from the object to the mirror, which we call DO, is the same as the distance from the image to the mirror, what we call DI. The only key thing, though, that we need to note is that DI will be negative. All right. We consider the mirror to sort of be the boundary between the positive and negative sides, and we always make the real side or the front side positive. So if we count, I have 1, 2, 3, 4, 5, 6 lines here, so this is DO, and DI must then be 1, 2, 3, 4, 5, 6 lines on the opposite side, and the same size, and I'm going to label it I for image. Next, what we need to do is draw an eye to represent an observer. And we're going to place a dot at the center of the eye. The students often ask, where do I place the eye? Do I have to place it somewhere? Unless it's given to you, like if you're told that the observer stands, an X distance away from the mirror, you can pick anywhere except two places that really don't work well. Behind the mirror really doesn't work well because measuring angles is just really difficult when you're drawing these. And in front of the mirror really doesn't work well because then you would be blocking the light. So I'm going to pick somewhere down here, draw my eye. Here's my eye. Okay. Now that we've drawn the eye, we draw the actual ray diagram. So we draw a line from the eye to the image. Imagine that you live in a society or in a world where you don't know about mirrors. If you looked in the mirror, you would think that this is a real thing, right? And sometimes this happens to us when we don't know a mirror is located somewhere. I remember a friend, for example, walking up to what he thought was just an open pathway because the reflection was really clear, and it turned out it was actually a mirror, and he smacked his face right into the mirror, right? So we think that light makes a straight path. Now the big thing here is that we want a dashed line behind the mirror because that's where the light doesn't actually go but appears to come from. And then we want a solid line in front of the mirror because this is the part of the light ray that actually exists. We make a dot here. So we place a dot on the mirror where the line intersects the mirror. So this is our reflection point. What we then want to draw is the second part here. We draw a line from the object to the dot on the mirror. And this was the original incident ray. So this ray here is the original ray, so we call it the incident ray. And this ray is the ray that results from the reflection, so we call it the reflected ray. Now the last step is to draw what is called a normal to the mirror at the dot on the mirror. So the word normal means perpendicular to or 90 degrees. So you would need a protractor, but we can still do a reasonable estimate. And it needs to be perpendicular to the mirror at that point. This is what we call the normal. The reason why we need the normal is that the angles that we want to measure are always measured relative to the normal. So this first angle here we call theta I. It is the angle of incidence because it's the angle formed between the incident ray and the normal. The other one we draw is right here. This is called the angle of reflection because it's the angle formed between the reflected ray and the normal, and the symbol is theta r. Okay, so two key points here from our sketch. DO must always equal DI. It also means that the height of the object will equal the height of the image. But DI is negative, so always have a negative value. We form congruent triangles, so theta I must equal theta r, and we form, so the congruent triangles, remember this triangle here is congruent with this triangle here. And then the triangle that forms with the observer is similar to the other two triangles because of angle, angle, angle. Right angle, right angle. Sorry, I need to sketch it right here. Same angles here, so same angles here. Let's do our little markings. 2, 3. 1, 2, 3. So by angle, 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 we form similar triangles. Let's also talk just a little bit about describing the image here. All right. The image is always, always virtual, and it's always upright. These two go together. Right? We call something virtual because it exists in not real space. I'd have to look into the mirror to see this, and so by looking into the mirror, I am not seeing an actual real forming of a light ray, but instead where light appears to come from. So just to look at a helpful little animation here of what's going on, when we have an object that reflects light off of a flat surface, at each different angle, the light ray reflects off at the same angle. And because the angle increases as we go further up or down, they all then appear to come from this image location directly behind. But because this exists inside of the mirror, so to speak, it is a virtual location. The light rays can't form in real space because they all diverge. But because they're not parallel, they seem to come from a spot which is back here behind the mirror. Now what we're looking at is this first type of reflection called specular reflection. And specular reflection is a term used when we have a surface that is so smooth that really anywhere across the surface the normal is parallel to the normal anywhere else. So notice these three normals are each parallel. And so as a result, when light rays all come in and hit different points, they'll all reflect in the same way and they create a very clear image. Diffuse reflection, on the other hand, is what most things that we look at are doing, which is we can see the light reflect off. Oftentimes you can see sort of a very unclear image. But because the surface is not perfectly smooth, what happens is that these normals, notice on these ridges, bend different ways, and in the valleys other ways. And the law of reflection is always obeyed, but the light rays don't reflect off at the same sort of predictable angle as they do up here. And so we don't see any sort of clear image. Things like the moon end up being illuminated, as we can see in this photo. Notice the sun is over here, so the light rays hit the moon and come to the camera. But because the sun is a very rough, the moon, is a very rough surface, we don't see a reflection of the sun. It's not like a big mirror. Instead, we just see the moon glow.